In this module, we're going to take a look at the answers to midterm number 1 in summer of 2015 for Econ 3100, which is Labor Economics, Section 90, the online section. This module will actually consist of 3 segments. In segment 1, we'll look at part 1 of the exam. So we're looking at questions 1 and 2, of which you only had to answer one of those. Segment 2, we'll look at part 2 of the exam, in which you have questions 3 and 4, of which you only had to answer one. I'll provide answers for both of them, of course. And then in segment 3, we have part 3. You'll recall part 3 had one question, and that was question number 5, and you had to answer question number 5. So let's go ahead and take a look at part 1 of this, problems 1 and 2. So problem 1, I've given you some information for BJSG Ribs in Mankato, Minnesota. They have a labor demand relation of labor demand equals 68 minus 2W. It's a profit maximizing firm in a competitive labor market with numerous employers. All firms have the same labor supply relation, which simply means that we don't have to worry about it. If they all have the same one, maybe for the information I'm asking for here, we don't even have to consider what it is then. They would all have a similar labor supply relation because they're all working off the same market of labor supply, and that the price of the output good that they're producing, ribs in this case, is $1.50 per unit. Well, if the price is just a set amount, that would suggest to us it's also a competitive goods market. So I've then given you values for W, the wage. I've given you values for Q, which is the quantity of output, so the quantity of units being produced and sold at this price of $1.50. I ask you for labor demand, marginal product of labor, the price, and marginal revenue product of labor. So to get labor demand, of course, all I'm doing is I'm substituting into the labor demand equation the wage value. So 68 minus 2W, or 68 minus 14, is 54. 68 minus 2 times 8, so 68 minus 16 is 52. And then we go ahead and just do that all the way down to a wage of 18, and we see we're going to go from 54 down to 32. To get to the marginal product of labor, we'll recall that the marginal product of labor is a change in quantity divided by a change in labor. Okay, so we've got a change in quantity of 6. We go from the first row to the second, change in quantity of 6 divided by a change in quantity of labor of 2. So we have marginal product of labor of 3. The next set of rows, we have another change in this case of 8 divided by a change of 2. So we now have 4. And so we can continue that down, that same metric. In the final 2 rows, we see that there's a change of 26 divided by a change of 2. So we have 13. So this is our marginal product of labor column. Then as we look at the price, well, I've already told you the price of the output good is $1.50 per unit. So we end up with $1.50 in every one of these cells. And if you had simply written $1.50 in the first cell and then a line coming straight down just indicating that it's carried out throughout, I'd have been fine with that. In fact, I was fine with that in a number of cases. And then we come to marginal revenue product of labor. And we recall the marginal revenue product of labor is equal to the marginal product of labor times the price. Well, we have 3 times 1.5, the price is 4.5. 4 times 1.5 is 6. 5 times 1.5 is 7.5. All the way down to 13 times 1.5 is 19.5. So that's part A or that's item A of question number 1. I then asked to, based on what we know about this profit maximization in this labor market, how many workers will the firm employ and what wage should they be paid? Well, what metric do we have to think about this? We know that profit maximization is where marginal revenue product of labor is equal to the marginal expense of labor. We know that's a general condition. We know that in a competitive market, the marginal expense of labor is equal to the wage. So that was going to mean for us then, if this is a competitive market, and it is, I told you that it was, the marginal revenue product of labor will be equal to the wage. Well, all we need to do is scan down the wage column, and then scan down the marginal revenue product of labor column, and find the row at which they're both the same, which happens to be at a wage of 15, marginal revenue product of 15, and we're showing here that we have 38 workers. So that's our profit maximizing number of workers in order to get the most that we can out of this environment. And they have a wage of 15, a marginal revenue product of 15, so we are paying them exactly how much they're bringing in for us, for our firm, and we want 38 of them. So it's 38 and 15. I then ask you something that harkens back to what's referred to as the balance condition. The balance condition. And I give you some information about marginal product of capital and then the price of capital. So I've given you MP of K is 45 and price of capital is 30. And so if you know that, and by the way, you know the marginal product of labor and the price of labor from the prior table, you can then figure out some profit maximization here as well. And we're using the relation marginal product of labor divided by the price of labor. We want that to equal the marginal product of capital divided by the price of capital. So what do we have? Well, we know that the marginal product of labor, when the wage was 15, and that's what we're paying these 38 workers, marginal product of labor was 10. So MP of L is 10 divided by the price of labor. How does that relate then to the price of capital divided by the marginal, how does that relate to the marginal productivity of capital divided by the price of capital? Well, 10 divided by 0.1 or 10 divided by 1.5 is going to equal 0.667, and similarly 30 divided by 45 equals 0.667. So we already have the balance condition established here. Apparently at this point, if we have a marginal product of capital of 30 and a price of capital of 45 at this 38 workers, we are at our balance condition. So what would you recommend in order for this firm to reach some level of profit maximization? We do nothing, don't change. They're already there. So let's look at problem number 2 now. Problem number 2, I tell you a story about John. John's a college graduate. That's important to us. John has some years of experience, similarly important, receives a wage of $55 an hour. $55 an hour times 40 hours a week times 52 weeks a year is an annual wage of $114,400, which is important to us because it tells us that John's probably a relatively skilled worker. Certainly is well paid, and highly skilled tend to go hand in hand. We know that. We see that John has a daily budget requirement of $562.50 a day. That's going to be based upon his tastes, his preferences, his household needs. We know that John receives $40 a day in personal income from some investment assets. Think of that as an endowment, of course. Well, if from that 562, 40 has come from his investment assets, that means that there's 522.50 that must come from his labor, or substituting leisure. And so we can then begin to think about what a model might look like here. We see that John's a supervisory employee, so there's no overtime premium if he works more than 8 hours a day. We see that his employer allows him to work and pay him for as many hours as he wants to work each week, and that John is constrained to 5 days a week. Okay, so that's going to be building a situation for us. Before we even go there, let's think about basic concepts or something very general here. If John exhibits some tendency to decrease his work hours as his wage increases, what's the labor-supply relationship reflective of? You'll recall this from the labor supply module. And so as we're looking here, so what's this? If he wants to decrease hours as the wage increases, then maybe we have some tendency where it's increasing to a certain point and then decreasing as the wage increases. So he's got that tendency. What type of supply is this? Well, this is a backwards bending labor supply. We always start with positive, of course, we have to, and then there's this tendency to decrease working hours as the wage increases. So it becomes a backwards bending labor supply, which is probably indicative of at a certain point the worker has enough combination between wage and labor hours to meet their budget requirement, and at that point they begin to work fewer hours at a higher dollar per hour, and they are earning approximately the same amount of money. So I was looking for the answer backwards bending labor supply. In item B on question 2, I say, okay, go ahead and assume that John's a participant in the competitive labor market. I actually told you that he was. That the output price of the good that he manufactures, or this firm is manufacturing, is $1,200. So the price is $1,200. What can you tell me about his weekly marginal productivity? Well, if I'm looking at the weekly marginal productivity, I'm going to be thinking about this in terms of weekly values and weekly changes. I don't know anything about John's productivity, do I? I don't know his quantity of output. I don't necessarily even know, perhaps, his number of hours of work, but I do know a couple of things. I know what his wage is if he's making his budget requirement, and he certainly would be. I know how much he's getting paid. He's getting paid $522 a day times 5 days a week, which turns out to be $2,612.50 a week. That's his wage. Well, if we have MRP of L equal to his wage, I can now think of some metric that lets me find marginal product of labor, because marginal product of labor is simply MRP of L equaling marginal product of labor times the price of the output good. Well, I know that this now is 2612.5. It equals some marginal product of labor times the output good price of $1,200. Okay. So then I can take and suggest this is 2012.50 divided by 1,200, which is going to equal the marginal product of labor for John, and that'll equal 2.18. Okay. So now let's think a little bit more about John's decision here. I've asked you in part C, or item C, for a properly labeled and an appropriately articulated. So label this, make it in good form, make it look good to me. I want to know about his labor-leisure trade-off model. Give me his daily labor-leisure decision. So all these values are going to be values that we deal with on a daily basis. Well, the labor-leisure trade-off model, as you recall, has some income-denominated variable on the y-axis. This is going to include wage, but it's also going to include endowments and other things perhaps. And then the x-axis is going to deal with this labor-leisure trade-off. On this model, we always think of this with leisure in the lead line. And we know that we have 16 hours of available leisure in a day, supposing that there's an 8-hour regenerative period for us as labor units. And so we can go from 0 to 16 hours of leisure. And we also know that if we're at leisure for 16 hours, then we're at labor for 0 hours because we only had 16 hours in our day. So if we're at 0 for leisure, we're at 16 hours of labor. Excuse me. Well, in this case, there's a $40 endowment. So at the same 16 hours of leisure, John's able to receive $40. So we've got a straight line coming up here, vertical line coming up to the $40 mark without him even having to get out of bed. Total leisure. And at that point, we have a curve that will go from this point to the y-axis. That curve will have a slope of negative 55. And that's going to represent to us then, at the y-axis intercept, the number of dollars that could be earned from labor in these 16 hours. So 16 times 55, which is going to be 880, plus the original 40, so $920 is what we should have here at the y-axis intercept. So with 16 hours of labor at $880 plus the $40 endowment, we can actually, if John does nothing but work, John's going to have $920. But we know that John's not going to only work. We know that John only has a budget requirement of $562.50 a day. And if I take that $562.50, subtract from it my budget requirement, he only has to earn $522.50 a day. Take that $522.50, divide it by his wage, that suggests that we've got 9.5 hours of daily labor that John's going to have to provide. So we have 9.5 hours of labor, and we can realize that that's 6.5 hours of leisure because together they're 16 hours, right? And then we can just take a point on the the x-axis, go ahead and bring that straight up to the budget curve, and that's straight over at 562.50. So his budget is obtained at 562.50 with 9.5 hours of labor, 6.5 hours of leisure. And that included both some wage income for the day and included some endowment income. Well, if that's the point at which he resides on this budget curve, that point being informed by his tastes and preferences, that's what caused him to choose $562.50. That sounds to me like that's an indifference curve, and it is. And so I just asked you to give me some kind of indifference curve here. If you gave it to me shaped the way that mine is, or maybe a little more shallow, or even a little steeper, that's fine. I just wanted it to be a convex shape following some of the basic rules of budget curves, or rather indifference curves, knowing that it's going to be tangent to the budget. So this then is the answers for number 1 and number 2 on part 1 of the midterm exam.